Okay, so now that we know the exponential form of a complex number, let's just practice writing a couple of different complex numbers in exponential form. So recall that the exponential form is re to the I theta, where r is the radius, which we call the modulus, and theta is the angle, which we call the argument. So one way to do this is for a very simple number, we can just plot it on the complex plane without having to use any formulas. We should be able to actually see more or less where the number lies and what its radius and angle are. So first of all, let's take the number I. Number I, recalling that this is the imaginary axis and this is the real axis, the number I just lives right there. That's the number I. So we can see, first of all, we can just read right off what its radius is because we're just looking for how far that number is from the origin, and we can see that the distance to the origin is 1. So it's going to have a radius of 1, and an angle. We can actually just see the angle by looking at it. The angle is 90 degrees, or pi over 2. In other words, if you really wouldn't need any help converting this point, the point 0, 1, into polar coordinates. Sorry, I wrote pi. I meant pi over 2. So we have an angle of pi over 2 from the positive horizontal axis, and a radius of 1. So that gives us r equals 1, theta equals pi over 2. So we can write that the number I is equal to e to the I. Let me write it technically in the full form. 1 times e to the I pi over 2. Or usually we would just write e to the I pi over 2. And this is, by the way, how you usually write these sort of complicated exponents. You write an I, and then in parentheses you write the angle. Okay, so there we go. So that's the first one. That's I. Now let's do 1 plus I. So 1 plus I lives right here. That's 1 plus I. And we can easily see is that this is, if I draw in that line there, we can see is that this point is the end of the hypotenuse of a 45, 45, 90 right triangle. How do we know it's 45, 45, 90? Because its two legs are the same length, so we know it's just an isosceles right triangle. It's also called a 45, 45, 90. So we can see that this is going to be 45 degrees, or pi over 4. Let me write that outside because I didn't leave enough space. This is an angle of pi over 4. And of course, if you wanted to, you could just use the arctangent method. You could just say that theta is equal to the arctangent of 1 over 1, the arctangent of 1, which again is 45 degrees, pi over 4. So how long is this hypotenuse? In other words, the distance between the origin and the point is going to be, by the Pythagorean theorem, or the distance formula, is just going to be the square root of 1 squared plus 1 squared, or square root of 2. So we have here we have a radius of root 2 and an angle of pi over 4. So we can write that 1 plus I is equal to square root of 2 times e to the I pi over 4. And once again, this is a true statement. I'm not saying that root 2 times e to the I pi over 4 is sort of a good, clever representation of 1 plus I. I'm saying that these two expressions are mathematically equal to each other, that if I actually do all the steps to calculate e to the power I pi over 4 and multiply the result by the square root of 2, I will actually get the complex number 1 plus I by doing all those operations. So that's what the meaning of that statement is. Now let's do negative 5. So negative 5 exists right here. Negative 5, it's that point. So once again, the radius should be fairly clear just from the drawing. We don't really need to do a big calculation. Clearly, the distance is 5. And by the way, we're always going to get a positive number. I mean, unless we're at the origin where we have a radius of 0, we're always going to get a positive number. It would be absolutely incorrect to say that the radius is negative 5. The radius is 5. 5 is a distance, which is always a positive number. We're going to take care of the fact that this is negative 5 through the angle. So you can see that what I do then is, if I draw the angle that the angle that this part of the x-axis makes with the positive x-axis, what I can see is that I have to turn an angle of pi in order to get to that point. So what we can see is that the radius is 5 and the angle is equal to pi. So this number, negative 5, is equal to 5e to the I pi. So even a run-of-the-mill real number has an exponential form like this. And why does this make sense? Go back here. I said e to the I pi is equal to negative 1. So what we're doing is we're taking 5 and multiplying it by this rather unusual form of negative 1, getting negative 5. So these are three numbers in three complex numbers written in exponential form. The basic process is find the polar coordinates of a given complex number, and then just apply the formula r e to the I theta to write it in that form, and that will be the complex number.